If the sun and the earth attract each other, why don't they collide? Hello, welcome. I'm going to say out loud two things that you surely know. The first is that the earth revolves around the sun, and the second is that just like the earth gravitationally attracts you, the sun gravitationally attracts the earth. You knew that, right? So, the question I have for you is this: if the sun and the earth attract each other, why doesn't the earth fall or get engulfed by the sun? What prevents it? If you don't know why, don't worry, because what I'm about to tell you will blow your mind. The answer is that the earth is indeed falling, and not exactly slowly. It is falling at a good pace. The magic lies in the fact that the fall fails. You will see it very clearly. Imagine I grab the sun and the earth and release them into space. What will happen? They will attract each other, and eventually, we will have a collision. But what if, in addition to releasing the earth, I give it a little push to the right? Well, the earth will be attracted by the sun, but it will also keep moving to the right along its path, impacting another place depending on the strength and direction of the push. I can control where the earth would fall into the sun. But wait, what if I give it a strong enough push to throw the earth out of the sun? What would happen then? The earth would indeed fall towards the sun, just like before, but the collision would fail. It would pass by the sun's side, moving up to the opposite side of the sun, and then it would come back down, avoiding the sun once again. This peculiar way of falling and never hitting is what we all know as orbiting. Essentially, it's falling and being accelerated towards an object, but having the correct lateral velocity to avoid it. Let's take a closer look at it. Thanks to the push we gave it, the earth has a certain lateral velocity, and if it were up to that velocity alone, it would continue moving in a straight line in that direction. However, the sun exerts an attraction on the earth, pulling it. This pull causes the earth's direction of motion to deviate, curving its trajectory. In the next step, the sun pulls the earth again, diverting its path once more. The earth wants to keep moving in a straight line, but it is only forced to curve its trajectory for a lifetime. In other words, it is the sun gravitationally attracting the planets that keeps them stably orbiting without deviating from their orbits. Gravity is not the only force capable of doing this. The tension within materials also creates the same effect. All these forces responsible for curving straight paths are called centripetal forces. Realizing this was one of the great achievements of Sir Newton. He understood that both an apple and the moon are falling, except the moon is fortunate enough to move laterally fast enough to miss the fall to the ground. By the way, who gave that little push to the earth to avoid it from colliding with the sun? The answer is no one. It was born moving that way. The solar system formed from a large cloud of material that, thanks to gravitational attraction and immense collisions, managed to form a rotating disk around the sun. Over time, the matter in the disk grouped together, forming planets and other bodies, each moving at the correct velocity. Rotation came naturally. In summary, orbiting is falling, folks. The space station falls, satellites fall, and the moon falls. It's crucial to understand this if you want to comprehend how crazy general relativity is. Don't forget to subscribe if you want to keep seeing more content.